So this is significant help. Yeah, it's up there with solutions. Right, everything is there. It's a significant provision of resources if you think that way. Even then, if you have trouble understanding any idea, you're very welcome to send me an email with the question anytime. Okay. You can come to my office next 3 days anytime you like, between 9 and 3 though. Not after 3. Normally, I'm not here around that time, but I come here very early. So if you can come anytime, I will be in my office. Right? Let's look at what resources you got for that. Information about test 1. It will be held at 5 minutes past 3, exactly at this time, next week here in this room. You would have time before the test. We have tutorial, right? So you can ask any sort of questions during that tutorial if you have. The test is designed to complete in about 35 minutes. However, I would give you full 50 minutes for that. So you would have extra 15 minutes in it to help you if you're stuck at some stage or not. What it covers all material from lecture 1 to lecture 12. Lecture 12 that we are going to do now. That means tutorial 2 to tutorial 5. Next week tutorial is also included in it. So you should have a practice at home, okay, on that tutorial, and bring any questions you have for the next week practice session. It makes sense? Okay. There are 10 short questions, each worth 5 marks. Test 1 from 2015 to 18 provides a guide to format and standard of Test 1 in 2019. So these past papers and solutions are available on LMS. Now, you're not permitted to use a calculator or a sheet of notes. So basically, you would have access to only a pen. That's the only thing you would need. The rest of the stuff I would provide. You will be supplied with a sheet containing a truth table for the basic logical connectives, the sheet that I circulated today, in case you want to practice all of these questions or tests before the actual test. So that I provided that sheet already to you guys. And a list of principal laws of logic are also on that. Your answer should include appropriate explanations on all working. Questions are not marked just on whether the answer is right or wrong. So if you only put the answer without explanation, that's not the only, that doesn't carry full marks. And it counts 15% on the final assessment. 15% is significant. In the end, what I noticed over the years, these two tests, which combine are worth 35%, these are significant marks. You should be trying to get as much as possible now. What happens in the close to the final exam, there are lots of other subjects that you are doing, and their exams are due as well, and difficult to prepare for one particular subject that well. So I would encourage not to leave everything for the final exam. So try as much as possible now so that you don't have to worry much about the final exam afterwards. Okay. Again, remember, these questions or these kind of ideas will again be tested in the final exam. If you prepare well now, that would feed into the final exam automatically. Any questions? Yes.
Is there any YouTube resources you could recommend for study?
Okay. I never looked at that, so I don't know. There are lots of resources. You can listen to my videos. You can watch them and do all the exercises which we have done here already without looking at solutions, and then comparing. Once you have attempted them, then compare with the solutions provided.
Are you intending on introducing any more assessed content for this test between now and next Tuesday?
Any more content? No.
For test 1?
No. For test 1, the lecture which I'm going to do now, that will be tested. After that, nothing.
Have you all provided all the material that we need?
Absolutely, except solutions.
What are the answers?
Yeah, of course, except solutions and answers. Other than that, yeah. So let's look at one test that I gave last year. Test 1. Right. Convert the decimal number to binary. So you should know this thing we did in the last week's tutorial, how to convert numbers to binary. So 42 divided by 2 and noting down all the remainders. 125 multiplied by 2 and noting down all the carried forward number to the 4th place. Now, 5 marks for that. Oh, very similar question. Convert the number. The number is written in hexadecimal. You're asked to convert that to octal. So, if I want to do that, let's look at that. So you want to convert 2b5.d16 into octal. So first step would be to write their hexadecimal representation. 2 is 0010. Fantastic. Okay. Okay. How about? Oh yes, it's not doing it. Only there's another guy who is looking at it. Yeah, there. Oh, yeah. Okay. So you have 0010, and B is what? 1011. That looks right. Okay. And what is 5? 0101. Yeah. Dot. What is D? 1101. Yeah. That looks all right. Good. Now what we want to do? We want to convert into octal. So we have to have them in blocks of 3. Remember, this is not the purpose of this lecture. I'm just, for curiosity, I'm just attempting one question so that, so you block of 3s because you want to convert them into octals. So after decimal, there is 1, and then you add extra trailing zeros. So your number is 1, 2, 6, 5, dot 6, 4 to the base 8. That's your conversion to octal. Agree? Okay. Yeah. Now let's move back just quickly. What other questions you would have? Remember, nearly have weightage equally given to contents of each lecture. All right, that we did so far. Question 3, use binary arithmetic to calculate. So you're asked to calculate multiplication. I might put division there. Was that?
Do anything else.
Anything else?
Yeah, like we can do division, we just like don't include it, so like you just need to understand.
Okay. All right. I'll think about it. I have not written the exam yet, test yet, so I'll do that. I'll do that on the weekend. Find the 8-bit computer representation of this number. So first you want to convert that into binary and then see how you would write that in 8 bits. A computer representation represents number in 32 bits as 1 bit for sign, 8 bits for characteristic, and 23 bits for the significant. So you have the exponent bias. So then you have to what you asked to do, find the first 20 bits of this number. So you're going to express that first in normalized binary exponential form. Sign is positive, that is 0. And then you're going to find characteristic, 8 bits of characteristic, and 12 bits are nearly given here to you. So extremely easy, nearly. Now question 6. that bring into you last week's contents about logic. That P, Q, and R denote it's hot, it's raining, and it's Friday. So first, we want this expression to be translated or like how you say that as a statement. Similarly, other things, and converse contrapositive that we did in the previous lecture today. Tables, question 8, 9. Exactly how you complete this truth table. That was part of the contents that we did in the previous lecture, using laws of logic that we did in the previous lecture and that we are going to do in the next lecture. And similarly, question 10 would combine last 2-3 lectures here. So yeah, and this table would be provided to you. Anyway, that's what we have for the tests, and I hope you do well in it. Any questions for me?
What happens if you don't exactly get the right marks? Do we get like another trial?
No.
A little fun?
No. All the resources, after having provided all the resources, no. 15% is good enough. If you want to take it as a warning, yeah, it's fine. Next 20% you try hard for that. No, if you keep doing this, then it never finishes. Yeah. The final exam, of course, if there are some legitimate reasons, then yeah. For this, of course, if you miss it, for some legitimate reason, I will give you another chance to sit. For legit reasons. Okay? It's not that, okay, hard and fast, you missed, you're gone forever. No. Now, if there's some reason you fall sick, you have some medical certificate with you, of course I will give you another chance.
What if you get a flat tire in the car? I don't know.
Okay, that's also legit. Yeah, do that. I don't know. Yeah, okay. All right, okay, let's start then today's lecture. The laws of logic. We're going to do, in the last lecture, we introduced the laws of logic. In the laws P, Q, and R, P, Q, and R can stand for any logical expression. Normally, we name them as atomic propositions. P is a standalone proposition or statement. It's Friday, for example. That may be P. Right? It is Wednesday. Okay, let's say Anne is happy. That's P. Q may well be something different similarly, and R may well be something different. The statement R and not Q is equivalent to not Q and R. It's called commutative law. You just switch them around, nothing more you did. You put not Q first, and then you put R. Yeah? It's the same. There's no difference. Example 2, the statement P and not Q or not R is the same as not R or P and not Q. So this is again, it's commutative. Right? You just put them in a different order. So it's a second commutative law. These are the laws that, similar kind of laws that we studied previously. Aim of this lecture is to illustrate and practice using laws to simplify logical expressions. These were the laws. You have a copy of it. If you don't, you can ask me for another copy. Right. If you have that, now we're going to use these laws to practice simplifying logical expressions. Use the laws of logic to simplify this expression. Would you like to do that, or you want me to solve it? You would never learn it if I keep solving it. What? Okay, I'll do it. Okay, let's see. What you have, P or Q, and not Q or Q. That's the first one. What I did, I used distributive law. This is what you're supposed to write. I use second distributive law, actually not the first, because I operate it from right. Okay? This is equivalent to P or Q, and now there is a statement, I am in the room or I am not in the room. This is universal truth. Always happen. Right? So it is always true, either you get head or tail. And what law is that? Can you tell me what law is that? Double what? No, I did not cancel anything here. It's the inverse law. Is it? Let me. I actually distributed probably all the sheets to you. Oh, I have it. I have it. I have it. So, you looking for P or not P? That has to be your Q or not Q. That has to be the second inverse law. As we said, second inverse law. Happy with it? Now, this is equals to, equivalent to, what law I'm going to use there? Look, I'm taking AND statement with a tautology of something. Identity law, exactly. So you would have P or Q, identity law. Three-step answer for that. So this expression can be simplified to just P or Q. You can verify your answer if you like in the end by constructing a truth table, if you like. It's not needed. Any questions? Yeah.
I missed the part how you got the T.
T is not Q or Q.
And what makes it N?
Not Q and Q. Or means,
Oh, it's or, okay.
yeah, this is or.
Yeah.
Head or tail. Of course, that will always be true. One of them always happen. So that's why it's a tautology. Head and tail. That never happens.
Looks like a 7. It's not a 7, is it?
Yeah? Happy? Does it look like? Not. Yeah. Okay. Alright.
Looks like a star.
So this is how I did that here in the notes. You can have a look. So basically this expression simplifies. By the way, if you find any typos on notes, please let me know. This is the time that I correct them. However, so far, never ever in 3 years anyone spotted anything. So, but you might be the first one to do it. Anyway, so it is strongly recommended that you set out your work as above, giving the name of the law at each step. Why not use truth tables?
Can take too long.
Yeah, exactly. Someone be listening. Yeah, it takes too long. Yeah. Anything else? Why not? It's boring. Yeah, and there is longer the way you do, more chances you have that you would make some kind of mistake. Yeah. And also, from the outset, we don't know what might be equivalent to. Right. From the outset, we don't have to know the precise truth values, true or false and all that. We can just, logical expression just simply states that don't find the variables, right? Just go for what it simplifies to. So you don't have to look for that. We're not interested in the truth values at all. We are interested in what it simplifies to. So it can be used to verify logical expressions, but you're recommended not to use it to prove equivalence. It would take too long. Anyway, how do you decide which law to use? you've done few examples now. How do you decide which law to use? There's no pet rule that, okay, you exactly have to use that law or something, or first go for this and all that. You know, your intuition, your practice will tell you that you're using distribution first, or you're going to use commutative first, or you're going to get rid of errors first. So it just automatically, if you don't get rid of errors first, it will keep bothering you, bugging you, and your expressions become longer and longer. So step one, my recommendation is to get rid of errors. Step two, if there is any distribution or brackets involved, try to solve them. All other steps you will find out yourself. It depends on question to question. In arithmetic, we have MAT1DIS rule, which was bracket, division, multiplication, addition, subtraction. We do them in order. Here, we don't have precisely those rules. There's a recommendation that you get rid of errors first and distribute use the distribution law. But other than that, it's just you have to see what law you're going to use. It might involve lots of steps to reach to a particular level where you can apply directly absorption law or other kind of laws. And that would just come with practice. So there are no fixed rules to determine which law to use when simplifying. We suggest you to get rid of errors. That means equivalent and implies statements. After this, try a law to see if it helps to simplify the expression, and that can only, you will be the judge to do that. And that can only happen when you've done a few questions to find out which law to use. So the process certainly gets easier with practice. Nothing else. So let's do some practice here, and if you have any questions, you can ask any time. Use the laws of logic to simplify this question. First, you have a go at it, and then I would I'll try to come up with some estimate. Yeah. Step 1, I just, as I said, got rid of arrows, and that law is called implication law. So that's how I proceed. Next, I look at laws again and see what law helps me. So there is some kind of, negation law. If you look at De Morgan's laws, I would apply De Morgan's law on it. And did you study De Morgan's law at school? Everyone? You should have, I think. You would have done when you did sets or something, no? Anyway, that's nearly, some years ago. I was about to say, I was about to say 20 years ago, but then realized that you're fresh. It's not. I've done 20 years ago. Anyway, well, De Morgan's law, if you look at, that says negation within the bracket, negation of P and Q is not P or not Q, but here our P is this. So not would go inside, so it becomes not P, or converts into and, this one, and then not Q, and then the other expression as it is. Do you agree with that? Okay. So then you have P and Q and P, and what not P, not and not cancels each other, so it's a double negation law. That I used. And then what we're going to have? What's the last law? What else we're going to apply here? What? Yeah, that is true. So P absorbs in it. Yeah, that's also you can use, or you can actually not absorption. You can use absorption if you like, but then actually there's idempotent law I would go with first. How that would happen? I would use firstly I would use commutative property to bring this P to the other side. However, it's your choice. You may want to not to use that. So then this becomes with this distribution property. Yeah. I went a longer way, but in the end, what I did, I'm going to use again absorption law, as he correctly said. Even though you used longer path, if you do it correctly, the end result would stay the same. So, P and P is idempotent P, idempotent law here, idempotent law, and P and Q. So you're left with the same expression that you did here, right? So even if you go longer path, you will go sort of loop the loop, and that would hint you that this step is almost the last step you have. Wait a minute. Let me put it equal sign here. So equality. So this would, after using absorption, I would have P and Q. Yeah. Do you agree with that? So basically from there to there, these steps are redundant but not incorrect. Okay. Even if you take a longer route and you think that, okay, you can apply some other law, if you apply them correctly, that would lead you slowly towards the final step that you want to apply. And remember, when you started solving this look a bigger expression. If at any stage your expression starts becoming bigger than that, that means you're on the wrong track. Any questions? None. Solution is here, and your answer is P and Q in the end. Remember, here the laws are sort of slightly different. The last one especially that's being used. Anyway, let's look at more examples. Use the laws of logic to simplify this expression. So now you can see that the only difference between this question and the previous question is instead of P, you got not P.
You are there?
Oh, that's okay. Okay, anyone has done it? What's the answer?
Is it not P or Q?
I don't know.
Probably wrong.
Probably. I have not done it yet. So, anyone else got the same answer? Not P or Q? Okay, let me try to do it. I have not P or not Q and not P. This is equivalent to not P and not Q and not P. This is equivalent to P and Q and not P. Yeah, and that is equivalent to not P and P and not P and Q. This is equivalent to F. I have not written the laws. So far what I'm getting, F and not P and Q. And this is it the same? Anyone else got the same answer? Or, yes, you got the same? Anyone else?
What was the answer?
F. Contradiction, yes. It's the statement is wrong, in other words. It simplifies to contradiction. That means all possible outcomes are false.
Because I had false and not P and Q.
So you had this version.
Yeah, yeah. Then I just,
You're taking and statement with the contradiction.
well, I somehow had it in English actually.
It is you're going to use F and P. That is annihilation law. Look at the annihilation law. That is any proposition and F is equivalent to just F. If you put and statement, if you have two statements where one is true, other is false, then the and would give you false. It requires some practice.
I somehow got the or sign instead of and.
Was you looking upside down?
Yeah, I probably
That's the only difference. Otherwise, they look the same. Right. So my answer is F. Okay. I hope you got the same. If not, you need practice. So please practice as much as possible. Questions, bring them to me. This answer means it's a contradiction. And yeah, that means all false possibilities. Now, last exercise, use the laws of logic to simplify this expression. Let's see if you can do this. Yeah. So this is the expression that I want to simplify. Not not Q or P and Q, brackets close. So there I put that in these brackets form. Okay, this is the question. So there are no errors. We don't have to worry about that. So first step is to solve the bigger bracket, or the small, the part, the contents inside. So first I use distributive law. You might want to use something else if you, I mean, it depends what you think. So I got this as an answer, Q and not P. Anyone got the same answer? 1, 2, 3, 4. Fantastic. It's promising to me that I might be correct. So this is the same as to say not P and Q using commutative property. Commutative law. So if your answer is not P and Q, that's also correct, I think. Okay. Symbols. Yeah, you can correct them with factors. That's not a thing. The main structure should be all right. So my answer is Q and not P, as explained here. Right. Any questions you have for me? I have a question.
Question.
Yeah.
What is the question?
Who will win the leads test? Question. No, leads. Ashes.
The Ashes
Yeah, the ashes.
on in 3 days, isn't it? I'll find that out.
Day after tomorrow. Day after tomorrow it's starting, but it lasts for 5 days. Next time I see you, it will be decided. So what's your verdict on it? Who's going to win?
Australia's going to win, so I said that.
It's going to be a draw. Well, they killed this.
Yeah, I know, they knocked him out.
It's in UK. It rains all the time. Why do we play cricket here? When it rains all the time. Was that?
What's T-Rex?
Ah, yes. Yes, lots of tea breaks. You know, when I was there, we used to go and play cricket, and we go to nearby suburbs and all that, and then the farmers would provide tea.
It starts on the 22nd.
Yeah, no, that's great tea.
For the Apple, yeah.
I know. All right, fellas. Any questions? Send me an email or come to my office. Prepare well for the test, and I hope you all do well.
Can we go over to the Ashes?
You can. I can't. I'm teaching, remember? Yeah. Not at the moment. All right. Enjoy, everyone. I will see you later.
Hey, you know how they had the East West Park before? And then the program came in. Yeah, she'll make about $12. Yeah, they were. Just that part, that's just all I get. Oh, so maybe I should just like one week in the other week. So I should whatever match.
Well, this one was recorded, so it might be. Oh man, that was the tutorial with much, isn't it?
Yeah, it's not this one. The other one. So I'm just wondering which one I should go to.
You should go to the one that doesn't clash with any other classes, which is on the Wednesday morning.
Because we had this tutorial with Tim.
Yeah, but there's another one on Wednesday morning.
Yeah, there's 2 tutorials. Yeah, I know. So I can just leave and that's not.
I think we just.
I'll let you know.
This place.
Yeah.